JEE Advanced 2025, Paper 2, Mathematics, Question 13. This is a numerical type question. Let us first visualize the problem on the complex plane. Omega is the cube root of unity located in the second quadrant at e to the power 2 pi I over 3. Negative omega lies in the fourth quadrant at e to the power minus pi I over 3. The sum of the geometric series will turn out to be 2 omega bar, which points into the third quadrant with argument minus 2 pi over 3. Here is the question. For a non-zero complex number z, let arg of z denote the principal argument with minus pi strictly less than arg z less than or equal to pi. Let omega be the cube root of unity with argument between 0 and pi. Let alpha equal the argument of the sum from n equals 1 to 2025 of negative omega raised to the power n. Then find 3 alpha over pi. Before solving, let us recall the key concepts. First, the cube roots of unity satisfy 1 plus omega squared equals 0 and omega equals e to the 2 pi I over 3. Second, the geometric series formula, the sum from n equals 1 to n of r to the n equals r times 1 minus r to the n divided by 1 minus r. Third, the principal argument of e to the I theta is simply theta, provided theta lies in the range minus pi to pi. Step 1. Identify omega. The cube root of unity with positive argument is omega equals e to the 2 pi I over 3, which equals minus 1/2 plus I root 3 over 2. Its argument is 2 pi over 3, which indeed lies between 0 and pi. Step 2. Express negative omega in exponential form. Negative omega equals 1/2 minus I root 3 over 2, which is e to the minus I pi over 3. Step 3. Compute the geometric sum. The sum s from n equals 1 to 2025 of negative omega to the n uses the geometric series formula with r equals negative omega. We need negative omega to the power 2025. Since negative omega equals e to the minus I pi over 3, this becomes e to the minus I times 675 pi. Since 675 is odd, e to the minus I times 675 pi equals e to the minus I pi, which is minus 1. Step 4. Simplify. Substituting negative omega to the 2025 equals minus 1, we get s equals minus 2 omega divided by 1 plus omega. From the roots of unity identity, 1 plus omega equals minus omega squared. So s equals minus 2 omega divided by minus omega squared, which simplifies to 2 over omega. Since omega inverse equals omega conjugate for a root of unity, s equals to omega bar, that is to e to the minus 2 pi I over 3. Step 5. Find the answer. Alpha is the argument of s, which is the argument of 2e to the minus 2 pi I over 3. The modulus 2 does not affect the argument, so alpha equals minus 2 pi over 3. Therefore, 3 alpha over pi equals 3 times minus 2 pi over 3 divided by pi, which gives us minus 2. The correct answer is minus 2. The sum evaluates to omega conjugate, whose principal argument is minus 2 pi over 3. Multiplying by 3 over pi gives minus 2. Here are some exam tips. First, always express cube roots of unity in exponential form for power computations. Second, use the identity 1 plus omega squared equals 0 to simplify expressions. Third, for e to the in pi, only the parity of n matters. Fourth, omega inverse equals omega conjugate for roots of unity on the unit circle. Finally, always verify that your argument lies in the principal value range minus pi to pi. If you found this solution helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB.